You know, when you look up at the night sky, you see all these countless stars. But a lot of those little lights are holding some pretty big secrets, telling stories that are way more complex than you might think. So today, we're going to put on our detective hats and solve a cosmic mystery to uncover what's really hiding out there in the dark. And that's really the big question for any cosmic detective, isn't it? That one single shimmering dot. It could be a lone star just like our sun, or it could be a clue, a hint that there's a hidden companion, or maybe even an entire undiscovered world. So the very first clue in our investigation is realizing that stars, well, they're often pretty social. A huge number of them don't travel through the galaxy solo. They actually come in pairs, or even bigger groups, all locked in this amazing gravitational dance. What we're talking about here is what astronomers call a binary star system. And it's not just two stars that happen to look close together. No, they are a true physical pair, gravitationally bound to each other, orbiting a common center of mass for millions or even billions of years. Okay, and this is a really important distinction to make. Sometimes you have two stars that just happen to line up perfectly from where we're looking on Earth. That's what we call an optical double. It's basically a cosmic illusion. A visual binary, on the other hand, is the real deal, a genuine gravitationally connected system. To put it simply, one's a coincidence, the other's a family. And believe me, this isn't some rare exotic thing. A lot of the famous stars you might already know are actually binary systems. Serious, yeah, the brightest star in our entire night sky, it has a tiny white dwarf companion. And Castor, in the constellation Gemini, is actually part of a wild six-star system.
All right, so we can see some binary stars directly with a telescope. That's cool, but what about the partners that are hiding from us? This is where the detective work, it really starts to get interesting.
This is the huge challenge astronomers are up against. I mean, if a companion star is way smaller, a lot dimmer, or orbiting incredibly close to its really bright partner, it just gets completely washed out. It's like trying to spot a tiny firefly right next to a giant searchlight. So, how on earth do we find these invisible stars? Well, we have to get clever. We have to use indirect methods, kind of like an astronomer's forensics toolkit. We can watch a star's light and see if it periodically dips, which is a big clue that an unseen partner is passing in front of it. Or we can look for a tiny little wobble in a star's path through space, a telltale sign that it's being tugged on by a hidden companion. Or we can use one of the most powerful tools we have, analyzing the starlight itself. This all comes down to something called the Doppler effect. You know how the pitch of a siren changes as it moves towards you and then away from you? Well, the exact same thing happens with light. Light from a star moving towards us gets kind of squished into shorter, bluer wavelengths. That's a blue shift. And light from a star moving away gets stretched out into longer, redder wavelengths, a red shift. So by watching a star's light cycle back and forth between red and blue, we can prove it's orbiting an unseen partner. Pretty cool, right?
All right, so we've sharpened our detective skills finding hidden stars. Now, let's take on the ultimate cosmic cold case, finding planets outside of our own solar system.
We call these extrasolar planets, or just exoplanets for short. And for centuries, we could only wonder if they even existed. Now we know they do. They are whole other worlds orbiting distant suns out there. I mean, just think about how tough this is. A planet doesn't make its own light, right? It only reflects a tiny, tiny fraction of its star's light. So finding one is so much harder than finding a dim star. It's like trying to find a single moth flying around that giant searchlight from miles and miles away.
So, how do we do it? Well, it turns out our trusty detective kit for binary stars is pretty much perfect for the job. Because think about it, a planet pulling on its star is just a much, much smaller version of a star pulling on another star. The principles are exactly the same. We just have to look for much, much smaller clues. And the most successful tool by far is something called the transit method. It's actually pretty simple. If a planet's orbit is lined up just right from our point of view, it will periodically pass in front of its star. When it does that, it blocks a tiny little bit of starlight, and that causes this minuscule repeating dip in the star's brightness. Finding that repeating pattern, that's the smoking gun that tells us a planet is there. And it's just wild what we can figure out from that little shadow. A bigger planet is going to block more light, which creates a deeper dip in the brightness. A smaller planet creates a shallower dip. By measuring that change with incredible precision, we can actually calculate the size of the exoplanet.
Of course, we've got a couple of other tricks up our sleeve. The radial velocity method, that's our Doppler technique again.
It's just like finding those spectroscopic binaries. We're looking for that tiny red-shift-blue shift wobble in the starlight, caused by the gravitational tug of a planet. And, in very rare cases, if everything is perfect, we can use powerful telescopes to actually block the star's insane glare and take a direct picture of the planet itself.
So, how do all these methods stack up? Well, the numbers really don't lie. While every single method is important, the transit method is the undisputed champion here. It's responsible for discovering thousands upon thousands of new worlds. It has absolutely blown the doors wide open on planetary discovery.
So, after all this searching, after staring at all these points of light, looking for all these wobbles and dips, what have we actually found? What does the census of our cosmic neighborhood even look like now?
You have to remember, for decades, the number of planets we knew about was just 8, the ones right here in our own solar system. How has that changed since we started using these forensic techniques on all those other stars?
Over 5,000. Let that sink in. As of early 2024, we have confirmed the existence of more than 5,300 planets beyond our solar system. In just a few decades, we've gone from knowing about one planetary system, ours, to literally thousands. The evidence is in. We live in a galaxy that is just full of worlds.
And a huge shout-out has to go to missions like the Kepler Space Telescope. It was built to do one thing and one thing only: stare at a single patch of the sky and use that transit method to find planets, especially the smaller Earth-sized ones. Its success has completely revolutionized our understanding of just how common planets are in our galaxy.
So the first great mystery, are there other planets out there? That one's been solved. The answer is a resounding yes. But it's just opened the door to an even more profound question. We've found thousands of new worlds. Now the real search begins, the search for signs of life. And to find out if, somewhere out there among those thousands of tiny shadows, there's another Earth just waiting to be discovered.